Hey everyone, it's me, Teddy. I'm back here with another programming assignment. This one is for my Software Development 2 class, CEN4025C. And specifically, this assignment we were tasked with writing a Java application that does three functions. Those functions would be to create a new method for an array list, a linked list, and a hash table. Specifically, our professor wants us to create a new method for each one of those three things, which adds, looks like 2 million random integers. I have my program assignments up there so I can see what's going on. But we did already create this program. I can go ahead and show you and talk a little bit about it. So while this assignment did not have a theme, I'm a very theatrical person. I like to go above and beyond for a lot of those things. So I mimicked it. As you can see, this application is themed around a Digimon data battle. For those of you who are not familiar, Digimon are digital monsters, and I figured this would be a good time to bring them in. When we're talking about programming, Digimon has a lot to do with programming and computers in general. For an example, not to give you guys too long of a background history, but areas in the digital world, including areas like the file continent or the server continent, they have a lot of entities which are computer based, and things like firewalls, stuff of that nature. So long story short, I felt it necessary to include it just because I wanted it to be a bit less cut and dry and a bit more me themed and exciting. Okay. So basically, like I said, this is to demonstrate the performance of different data structures, the array list, the linked list, and the hash table. So we're just going to go over our main method here. Since this is our main application, there is only one method, if you will. There is no other method for this. Or excuse me, there is no other class for this. The methods are within this one class. Excuse me. So here's our first argument, our main method here. And this is the digital world's battling arena. This is where all the data battling is taking place, so to speak. The way this will play out for us is in a command line interface. That way we can see everything we need to see. Okay, so these are some public messages that we're going to say. Welcome to the digital world battling arena. Just, welcoming people in. We're going to give them the challenge for the day, which is processing data. There's several different Digimon. And these Digimon are going to be Patamon. As you can see here, Patamon represents the hash table. Wormmon does the linked list. And Vmon is the array list. Now, mind you, it says attack at that. That's just because Digimon attack stuff. Like I said, I want to incorporate Digimon as much as I could in this process, so some of the verbiage may be weird to those who aren't Digimon fans, but that's okay. I mean, that's what learning about Digimon's for. That's why I'm here creating a program. Okay, so since we've talked about all that, let's get into each of them individually. Okay, so this is Vmon, and this is for our array list. We obviously have our system printout that's going to let the user know when they get in the command line interface that it is an array list and that it's going to be the data. As we can see here, here's our array list, and we're going to put it as a data list. And we're going to have it show a start and an end time. That way we can check to see how long the processing actually took for this one section. And here's some of our additions, if you will. Some more of our Digimon ease, if you will. For adding data, it's going to be Vmon v headbutt. That's his main attack. Since we're adding stuff, that's our main thing that we need to do. And then we're going to have it put in random information. And we want to see in end and start and end time for how long it took to do that attack. And then we're going to display it in milliseconds here. And then the second one, after he is added or attacked, we're going to want him to clear the data or delete it. So we have Vmon here, and again, it's going to show us as deleting. It's going to delete from that list here. And then we're going to display it to the user and how long it took in milliseconds. So as we can see, the end time, start time here. Wormmon, same thing, but for LinkedList, he's going to have attacks for addition and deletion as well. When it's Wormmon's turn, it's going to let you know, hey, we're switching over to the LinkedList. We're going to show the silk thread is the adding data. Clear the web is them deleting the data. You know, as the internet, I could have said clear cache and cookies instead of clean up the web, but it's not clearing cache or cookies, so I didn't think it was appropriate. Clear up the web was kind of a play on the fact that Wormmon shoots out silk thread. Okay, and then here we can see once the data is deleted, it displays it as it did for VMon's creation and deletion. And finally, we get down to Patamon, who uses the hash table. And hash tables are the key value system, and it's used for very fast lookups and for very fast adding and deleting. If I remember correctly, there are some issues that can arise with hash tables, and using them exclusively. Generally, we want to use a multiple of these methods and tools at the same time, not just one, to prevent, improper deletions. We want to make sure, like, let's say Patamon's going through and he quickly deletes things, well, then he may miss some stuff, whereas, like, this line up here, Wormmon may catch it, more thoroughly, or VMon may catch it more thoroughly. The reason why I picked Patamon flies, I figured Patamon was faster. However, if we want to split hairs of the anime itself, this would be VMon, because VMon tends to be the person who rushes through things to get them done more quickly, and Patamon tends to be the more reliable one. But Digimon references aside, we're here to see this code in action, correct? So let's go ahead and run it here. Not only we're going to run it, but we're going to look at some of the performance data of it once it did run. And as you can see, welcome to the Digital World Battle Arena. Today's challenge, processing 2 million data packets. As you can see, we have VMon using the ArrayList. He V headbutts, and then he clears the data. So the data took 244 milliseconds to add data and 19 milliseconds to delete it. For Wormmon, it took the linked list took 480 milliseconds to add the data with silk thread, and to clean the web or delete it, it took 36 milliseconds. So generally, based off of what I'm seeing here, it generally takes more time to add the data into the system than to remove the data. And as you can see, finally, for Patamon, Boom Bubble is their final attack. That's their adding data. It took 263 milliseconds. And then clearing the air, aka popping all those boom bubbles, it took 114 milliseconds. Based off of this, it looks like adding data into the hash table took longer than it did for VMon to add in his data. But it generally still does keep that pattern of adding data takes longer to delete it. Perfect. Now that we got that all the way, let's go ahead and run our little profiler up here. For those of you who can't see, I'm going to just go click up here under more options, and we're going to go profile with IntelliJ Profiler. I'm going to see some stuff pop up here. You're going to see the same program running and stuff like that, but we're going to want to see the performance over here. Just click open. We're going to go over our call tree here. As you can see here, the execution time of the entire thing took 1,058 milliseconds total. As you can see here from our methods, here's Wormmon's linked attack. A lot of processes that ran in these quick amount of times. And then here you can see Patamon and VMon. The reason why they're up here, as you can see, this is based off of CPU time up here underneath my monitor, or my picture here. So it is taking you in the sort of execution time the largest amount. So the whole program itself took the longest amount of time, but it looks like just barely in own execution time, VMon took longer than Patamon. Over here, own execution time, I'm not sure what that reference is, but it looks like it was a lot more closer, and Patamon took a little bit longer, but it looks like for the overall execution of the program, VMon took the longest amount, or rather, the ArrayList took the longest amount of time to run. Just going to go over a bit more of our stuff here, as we can see. This is how it all went down. There's a lot of processing power. Ooh, 100% CPU usage for this section. Nice. And then our events here. I'm going to show all of the events that this program took place. And then these are for our profiler itself. So yeah, you could do a search method here, and let's say we want this one here. As you can see here, 1 maybe. Apologies, locating some of this data and extrapolating it into, graph form is still something I am working on here. But yeah, as you can see here, my program does work properly. It does, in fact, show the profile data here. And just to reiterate here, as we can see based off of this, which sections took the longest to run, it would be this section here. So yeah, this is my Digimon data battle profile slash array list slash linked list slash hash table assignment for my programming class. Thank you guys so much. I hope you have a great day. Ja, mata ne.